review 12 notes, starting off with basic concept, FTC2. You don't actually have to know the names of them. I keep putting the names because that's how I know them. FTC stands for Fundamental Theorem of Calculus. This was actually the first one we did, even though it's called number 2. We learned them out of order. So FTC2 is used for definite integrals. Okay, so it's used for all your definite integrals. You don't even think that you're using it. You don't give it a name. But anytime you're asked to find the integral from a to b of a function, you are using FTC2 because that's the actual theorem. Theorem states, find the antiderivative, substitute in b, subtract f of a. So you use that all the time, okay? Then there's also the application of it, meaning you're used to doing that if they just tell you to find the integral. Where you have a little bit of trouble is when they try and apply it. I'm going to write the same exact thing, only instead of calling it f, I'm going to call it f prime. Because sometimes you forget that if they ask you to integrate a derivative, you're not finding the function. You're finding the function at b and subtracting the function at a, and it's not even the actual function. This antiderivative that you find is not the function that you think it is. You think it's the full antiderivative. What's missing? That plus c. We don't use a plus c when we do a definite integral. You actually can use it. It cancels out if you do. Okay, that's why we don't do it. All right, FTC rewritten. So you'll see, I'm going to use, I guess, this guy. I'll use this one. So rewritten means instead of writing it this way, they may ask you to find f of b, which is the same as taking f of a plus the integral from a to b of f prime of x dx. And that's the one that most of you use incorrectly. You forget about it. When I ask you to find the derivative, I ask you to find the derivative at x equal to 5. And that's all you need. You don't need any more information. You find the derivative, substitute in x equal to 5. If I ask you to find f of 3, you need this, that initial point. And if I don't give that to you, then you're stuck with a plus c. You actually can't find f of 3. Where have you used this the most? Or is like the most common place you've been forced to use that position? So at this point, I would hope that you remember if I ask you to find where the particle is at time equal to 7, you need to know some point where it started. I don't care what time, but I need an initial point, and I need to know the velocity. You need to know that information. So what this translates to is the application is if you know a derivative, you can only find actual values on the integral if you know an extra one. It doesn't work the nice way that derivatives work. All right, so I actually very messily wrote this. So f of b equals, I'm just going to rewrite it. You guys already have it. Is used when a derivative is given, and you might not even realize it's a derivative. They're not going to call it a derivative. They're going to name it f or g or r. When a derivative function is given, an initial value on the antiderivative is given, and you are asked a value on the antiderivative. We'll just call that AD. So that's like putting the pieces of a puzzle together. If that puzzle comes with a function who you don't know is a derivative till the question comes. So what do I mean by that? I'm going to leave that up there in case you're still copying. If I give you a function r of t, I tell you R of t is given in gallons. Actually, we did gallons yesterday. Let's do centimeters cubed per minute. Number one, that is a rate. It's definitely a rate because it's per minute. Whose rate is it? Volume's rate. So this is actually V prime. So this is a derivative. And then at some point it tells you, well, the volume at time equal to 1 is 500. Or 5,000, I should say. Because I wrote an extra 0. Therefore, find the volume at 5. I'm not going to call it V prime. Sometimes they do, and you'll be lucky. If not, the units work out that I can tell that this is volume's derivative, and now they want me to find a volume at 5. Gave me a derivative. Here's my antiderivative. I need its value. If you want the value using an integral, you need an extra value every single time. Okay? That extra value is what takes care of the C. All right, application of FTC2, you don't have to write that. That actually was the application. I keep forgetting that this is in the flip chart. I am going to very quickly go over the concept that's in here, why FTC2 hides in your free response questions. Do not go crazy trying to copy this. If you're very curious about the problem, you can write down 2007 question 2 and search it online, but I do not need you copying the whole thing. Okay, I just want to talk through the question. So at the beginning, they're telling you the rate at which the water enters and the rate that the water goes out. So the water's rate, I'm just going to call it W prime because water would be W. Prime is the rate of it. And we can say that that is F of t minus G of t, because if I take the rate which it enters, the rate which it comes out, and subtract them, I'll be left with the rate of water that there really is. So that's just something that you would have figured out from A to B. It's part C I want to talk about. So without really reading everything, read your part C. So the question says greatest. What kind of problem? Max. Okay, optimization. So this is an optimization problem. I would need to maximize how much water there is. So that would be this function. So whose sign chart do I make? So we're not doing the problem, we're just talking through it. Whose sign chart? W prime. So I'm going to need W prime sign chart. Okay. I'm going to make a fake one. I don't want to do the whole problem. All right. What else in that prompt is extremely important? Jamie, what else in the prompt is extremely important? Considering it's a maximum problem. From 0 to 7. That's important. Why? What are those? Endpoints. All right. So those are the pieces of information that are important that you also tend to forget. So I'm going to make a fake sign chart from 0 to 7. I'm just going to say that this is at A and this is at B. I have no idea how many zeros it has. We'll say this. And then I'm going to say we're looking for a maximum. So I'm going to say that this is a max, and no, this is not the answer. I actually have no idea what the answer is, and that's a max. How do I know which one is the maximum, Travis? How would I know if I have two options? Well, one of them, so I tested both of them. This one's a maximum, this one's a minimum, this one's a minimum. Those are my two maximums. How would I know which one is the absolute max? And not by calculus, but in general. I have 2 points. How would I know which one is the max? So go back to the original formula. I'll do it the easier way. If you looked at a graph, how would I know which one's the max? The higher one, right? So I just need the higher y value. So I need y values. And that's the part that's a little bit tricky. So I'm going to shrink this down now that you kind of hear what I'm trying to get at. I need the y values. So I need w of 0. And I need w of whatever that b value is. Remember the function they gave us? Was the prime. So this is that weird sentence I made you write down. If you're given a derivative function and you're asked to find the antiderivatives values, you need an initial, and I'm going to highlight it. It is here. At time equal to 0, the amount of water in the tank is 5,000 gallons. So it's 5,000 gallons plus the integral from 0 to 0. That should make sense. We didn't even need it there because they told you how much it was. 5,000 gallons plus the integral from 0 to b of w prime. So that's the FTC2 problem that's extremely common. It's so common that I kept giving you that same type of question on all your tests. And some of you liked it because you just kept getting it right every time, and half of you kept getting it wrong. Why? That's one reason. You're using an antiderivative, you're using an integral, you need an initial value. Other reason? Those are your two major reasons, the things that you'll forget. Okay? Otherwise, most of you know how to do those problems. All right. It actually had only one candidate. I forgot. I actually wanted to show you that. This is how the AP test writes their key. They actually always test both endpoints every single time. I only test the one that I mark as a max or min, and that's actually okay as long as you're proving why only one of them might be a max or a min. Okay? All right, substitution. Let's go back through and let's try to remember how to do a substitution problem. I'm actually going to do substitution just by an example problem, and then we'll note a few extra things. So I'm going to give you a minute. Let's see if you can actually do the substitution problem that's there. I heard someone say that that's the antiderivative of sine. At the moment, it's not, but if it was, I want to show you which one would be. That one would be. It's like such a small little difference. So let's go through how we know, because that's part of it, is how you know this has to be a substitution problem. Why does it have to be? Take your inside, mentally think of the derivative, and then ask the question, is your derivative, does anyone know the ending of that sentence? Thank you, Isaac. I don't know. Isaac has like some ridiculous memory of everything I've ever said in class in life. You really do. So, your derivative of what you consider your inside or your u has to be multiplied by the dx. Okay? And the constant doesn't matter. It actually doesn't need to be 2x. You just need an x. Okay? That's how I can tell that this is substitution. This one, if you made this u, its derivative, which has an x in it, is not multiplied by dx. Therefore, it's not substitution. And another one that wouldn't be substitution, any absolute value would not be substitution. Okay, remember that, please. So at that point, I think most of you guys are in the same place. I'm going to get started then. I'm assuming you all did that part. All right. That's not normal. So the next step is to find the derivative. And this problem is with respect to x. That would be negative 2x. And then solve for dx. So du divided by negative 2x is equal to dx. Because this is a definite integral, you're also going to have the extra step of finding the new limits. In this case, u of 1/2 would be 1 minus 1/2 squared, which is 1/4, so 3/4. And then u of 0, which is 1 minus 0, so that's just 1. Therefore, the brand new problem will end up having those limits. Before I get to the problem, let me rewrite our integral. Would be 2x in the numerator, square root of u in the denominator, times dx, which is now du over negative 2x. So that would cancel. And so the new problem will be the integral from 1 to 3/4 of negative u to the negative 1/2 du. And now you don't have to worry about these x values anymore. You're going to redo this whole problem using u values. So the antiderivative would be add 1 to the power, divide by that power. So it's actually 2u to the 1/2. F of 3/4 is equal to 2, whoopsie, square root of 3/4. F of 1 is equal to, let's see, 2. Therefore, don't forget that we had this negative out here. Negative. So square root of 4 is 2, so that just gives me root of 3 minus 2, which would be 2 minus root of 3, so letter E. So those are the steps for a substitution problem. You guys also have to make sure to remember to change your limits because they do test that on the AP. A few last things to remember. I gave you this list over here of how to know if you would need to use substitution. The other type of problem, just an ln problem. LNs, in terms of an integral, always look the same way. You can have a constant in the numerator, but in the denominator, it is a linear function, and then dx. That's how you know that that's a substitution for ln. That would be your u. Going back to your homework, I actually forgot to add something to the front. Your homework then is review 12 and the entire 2009 test. The test is section 1 is 55 minutes. Section 2 is 50 minutes. Those are your multiple choice sections. Section 3 is 45 minutes. And section 4 is 45 minutes. Just a reminder, if you were to do, because these are free response numbers 1, 2, 3, if you finish those early, you can't add that time to section 4. They actually do cut in between each of these, and then they do not let you go back to a section. And that's just a reminder. Please make sure you have the 2009 test completely finished by the Monday we return, and please check your answers and go through which ones you are getting incorrectly. The Scantron, please keep the Scantron clean because I do want to run the Scantron.